Okay, we're going to look at a short little video here and get familiar somewhat with the calculator. That's what this one is about. We're going to be accessing the menus in the stat program, which are L1, L2, L3, L4, L5, etc. And they're located above the numerical keys 1 through 6. Now in this calculator, they're in blue ink, and to access them, we just hit the blue button, the second button. So if I want to go into L1, or if I want to type L1, if I want L1 to show on the screen, I just press the blue key. Oops. I just press the blue key and the number 1, and there's L1. And that's pretty much all there is to it. Also, in this little short discussion, we're going to be using the store button, which assigns numbers to a memory location. Okay, so let's look at it and see what we can get into here. So here's the handout that's on Canvas, and we're just going to look at this numerical problem. We're integrating e to the minus x squared from 1 to 3. Now, it's not possible to find an antiderivative for e to the minus x squared. So you're going to have to use some sort of numerical approximation if you want to evaluate this. Now, interestingly, on the next material we study, which is infinite series, we'll learn how to create a polynomial that can approximate e to the minus x squared to any degree of accuracy we want. And then we can learn how to integrate that polynomial really simply. So there's ways to find this, even though it's not possible to find an antiderivative. Okay, first order of business is to define delta x. So delta x, we're integrating from 1 to 3, so this would be 3 minus 1, and there's going to be 4 subintervals. So delta x is going to be 2 over 4, or 1/2. Okay, first order of business. Now the second order of business, we want y1 in our calculator to be the function e to the power minus x squared. Okay, so on the calculator, to access the exponential function, of course, we hit second and the natural log, since they're inverses of each other. So if I press second natural log, you see I get the exponential function. Okay, so let's hit the y equals button. We're going to create an equation, get rid of the old one. We hit second log. Now I want to hit the minus key, which is this key. Subtraction will not work. I want to hit the minus key, the x variable key, the exponent key, the rooftop, squared, close the parentheses. So y1 is going to be e to the minus x squared. Okay, clear screen. Good to go there. Now let's go back to the handout. This is going to be the midpoint rule, so I'm going to have to use midpoints. So let's draw our little number line. And we did this earlier in the semester. One of the first things we did this semester. Now there's 4 subintervals, so we begin at 1, and then so there's our 4 subintervals. Now where you start, of course, is always x sub 0. Now x1 is simply going to be where you start plus 1/2, so this is going to be 3/2. Okay, but we're doing the midpoint method. So for this subinterval, we need to find the first midpoint. Okay, so the first midpoint will just be the average of these two endpoints. So we want 1 plus 3/2 divided by 2. So that's going to be 5/2 over 2. So the first midpoint is going to be 5/4. So that's your first midpoint. It's x sub 1 with a bar over it. We're borrowing the notation from statistics. Okay, then this would be the second midpoint, third midpoint, last fourth midpoint. So if you look at the subscripts, this column here in the table is for the subscript of what's going on in the problem. Our first subscript is 1 and goes to 4. Now, I've got to get this element right. If I get the first midpoint correct, then I'm home free essentially. The calculator's going to do all the drudgery for us. The first midpoint is 5/4. And then to get all the other midpoints, this is 5/4. To get all the other midpoints, we simply add delta x. Well, delta x is 1/2 or 2/4. So then we have a 7/4, a 9/4, and then an 11/4. So there are all the midpoints. Now, we're going to enter them into the calculator and we're going to put them in list L1. So let's go through the mechanics of doing that. So make sure you've got what I've got here and take a moment. Make sure you agree with what we have here. Okay, so calculator time. I want to list these values under list L1. To access list L1, we just hit Stat, Edit. And all I'm going to do is just type 5/4 in, hit the down arrow. So 5 divided by 4. 5 divided by 4, hit the down arrow. Then go 7 divided by 4. Okay, down arrow, 9 divided by 4. And finally 11 divided by 4. Okay. Pretty straightforward. Now let's get a clear screen. Just quit. What we're going to do now, what we wish to do, is take these numbers one at a time and plug into the function y1. And then that's going to generate y values. And the y values are going to be the function evaluated at these midpoints. Okay, to do that, it's in my opinion, it's always been interesting the way they program this. To do all that, to do the simple thing of taking the function y1 and plugging in list L1, to get y1 on the screen, you hit the vars button, right arrow, and then enter. And we're going to hit enter again. If we wanted to hit y3, for example, if we wanted y3, if we had an equation for y3, we would either scroll down to 3 or we just hit the number 3. But we want y1, so we'll just hit enter again. That puts y1 on the screen. Left parentheses. Now we want to access list L1. L1 is directly above the number 1 key on the calculator. So we hit the second key to access that menu. Hit 1. That types in L1. Close the parentheses. So the function is going to take each of the numbers in list L1, evaluate them, and then it's going to spit out a Y value. And we want to store all those Y values in list 2 right here. So I hit the store button, which shows up on the screen as just an arrow, and then I'm going to hit second L2. And then finally enter. Now those are all the values. You see the 0.2096113872. That's what we're going to write down here. Now to scroll, we just use the right arrow. Now some students were saying that they couldn't scroll like this. Well, if that happens, just hit clear. And now just hit second enter. And see, the calculator remembers the last few keystroke sequences you did. It remembers this one. So to access them, I just hit second enter. If there's another one I want, I just hit second enter again, and then second enter again, and so forth. So just hit second enter, and you'll run through them slowly. And that's what we want. That's the one we had on the screen earlier. So we got Y1, evaluated at L1, stored as L2, hit enter. And now those numbers are what we copy down. And this is where you get them. You don't go into stat and look at them as a list, because just due to space, they only keep 2 or 3 decimal places. So we scroll across and write them down. Now, I'm not going to do that. I've already got it prepared, so I'm just going to lay it over the top of this one. Okay, and it should look now like this. There's all the numbers. Okay? Those are the 4 numbers that the calculator gave us. And remember, we put these in L2. Now, right here in the red ink is the definition of the midpoint rule. And what we need then is we need the sum of these f of x sub I. We need to add up this column. But remember, this column is L2. So all we need to do is find the sum and then plug in L2. Okay, to get to the sum command, I'm going to get a clear screen. To access the sum command, it's actually in the list menu there, right above stat. So I'm going to hit second, press the stat button, and now I'm accessing all the information from the list menu. And by the way, this is another way to get L1 and L2 on the screen. But I want to scroll over the math, and then you see the sum command is down here at number 5. So if you just press 5, you access the sum command. We want to plug list 2 in. So I'm going to press second and the number 2. There it is. Close the parentheses and hit enter. And now you see this number I've got written on the calculator. That's what I get when I add up these Y values. Now, to finish the approximation of the integral using the midpoint rule, I need this sum of the Y values, which is this value right here, times delta x. Well, delta x is a half, so I need to multiply this number by 1/2, which of course is the same thing as just dividing by 2. And there it is. There it is. So we see down here our approximation. The integral from 1 to 3 of e to the minus x squared dx is going to be approximately this value here. Now, I took the liberty of actually calculating this integral using fint, and we're going to assume this correct. And notice we only get 2 places of agreement, 2 places of accuracy. Well, it's not going to be a very good approximation with just 4 subintervals. But still, even with just 4 subintervals, we get agreement to about 2 decimal places. That's not bad. Okay, so there it is. Take a second. Make sure you get what I get. And let's move on to the trapezoidal rule. Okay. So the trapezoidal rule. Blank sheet of paper. Okay, so recall that we're approximating the integral from 1 to 3 e to the minus x squared dx. We're using n equals 4, and delta x is going to be 3 minus 1 over 2. I'm sorry, 3 minus 1 over 4, which is 2 over 4, or 1/2. Okay. Now, let's draw our number line. So we're beginning at 1. We have 4 subintervals. Okay. Where you begin is always x sub 0. So this one's going to be x sub 1. Like that. Now remember, delta x is 1/2. So this is going to be 1 plus 1/2, which is 3/2. If we add another 1/2, we get 4 over 2, or just a 2. So this is 4 over 2. The next one's 5 over 2. And this would be 6 over 2, which is 3. Now, if you simply look at what we've got there, and remember, in the trapezoidal rule and the midpoint rule, you use all the endpoints. That's why, if you notice, our table has 5 entries. So the subscripts, and the I column is the subscript. The subscript begins at 0. So we're going to have 0, 1, 2, 3, 4. And then x sub I, see, this would be x sub 0, where we start. This would be x sub 1, which is 3 over 2. 4 over 2. 5 over 2. And 3. And we're going to call this list L1, and that's where we're going to put those values into the calculator. Okay, so we're going to plug those into the calculator, so let's just go ahead and do that. Now I'm going to hit stat, enter, and now I need to get rid of the values I've got from the previous problem. To do that, we simply, you see where the cursor is, I'm going to move it up to highlight L1 and then clear down arrow. Go over here. So now I've got a clean slate. And I just want to put these numbers under list L1. So we type 1, down arrow. 3 divided by 2, down arrow. 4 divided by 2, yeah, that's right, you can say 4 divided by 2. Notice what the calculator does. It says silly, 4 divided by 2 is 2. 5 divided by 2, and then 6 divided by 2, which is 3. Okay. Now we can get a clear screen, no problem. The calculator's not going to erase those values. Now, just like last time, I want to get these y values. I want to take these numbers in list L1 and plug into that function. So what we need to get the numbers in the f of x column, we need to take y1, evaluate it at L1, and we want to store that as list 2. Okay? Well, let's do that. To get y1 on the calculator, vars, we have to hit the vars button right there. The vars button, right arrow, enter, enter. That's what we have to do to get y1 on the screen, left parentheses, and then remember to access L1, it's second key and then number 1. Close the parentheses. Now we want to take those numbers, those are going to be y values, and we want to store them or deposit them. So hit the store button into list L2, second L2, enter. Okay, now see those values, the 0.36787. Each one of those are going to go there, and you just scroll through and write them down. Now an interesting thing happens. Let's scroll all the way to the last one. Look at the last one. The last one's 1.23409, etc. 1.234 e to the minus 4. That's scientific notation. So all I want to do is move the decimal to the left 4 places. So that means that last number is going to be the 0 point, and then there'll be 3 leading zeros, and then a 1. So that's just scientific notation. That E is your calculator's way of saying 10. So this is 1.234, 10 to the minus 4. So we simply take that decimal and move it 1, 2, 3 places. So that means there'll be 3 zeros, since that 1 is one of the decimal places. Okay, makes sense? So now I'm going to just take the sheet I filled out and let's look at what you should get. So here are those numbers. And see, here's the last one. The decimal, let me get another pen. The decimal was right there originally. Now it was 10 to the minus 4th, so 1, 2, 3, 4 places. Small number. So make sure you've got those numbers. If not, scroll backwards into the video and see how to get those again. It's just this command right here. Okay, now here's here's Trapezoidal Rule, delta x over 2. And what I need to do is get this number. This is going to be a number in our problem. So notice that coefficient's a 1, and then they're all 2's until you get to the last one. So I need to create this M column, M for coefficients, in the calculator. We're going to put it in list 3, and it's going to be these coefficients, a 1, a 2, 2, 2, and then the last one's 1. Okay, so let's do that. Clear screen, hit stat, enter, and I'm going to put that as L3, so let's go over. See, here's the y values, and notice that they're just 3 or 4 decimal places is all it lists. Now, interestingly, see, notice this now that your calculator does this. When this first value is highlighted, here's the numerical representation down here. If we go to the next one, there's that numerical representation. Okay, so let's go over here and let's put in a 1, a 2, 2, 2, and a 1. Whatever you do, these coefficients, make sure you have the same number as here. If not, if you have 1 too many or 1 too less, if you have a different number than this, you'll get a dimension error in a second. Okay, now I'm going to get a clear screen. So, what needs to be done? To get these numbers in the parentheses, I need to multiply this list by this list. And see, I'll have one of these, I'll have two of these, which is what that says, two of those y values. I need two of those y values, etc. So I need to take this list times this one. So on the calculator, let's just do it. I want to take list L2, just hit times, list L3, and I want to store that as L4. So I'm going to hit second, and L4 lives right above the 4. Okay, now if we hit enter, and then what you've got, see, you're going to use and scroll across, but that's going to be my first entry. See that number there? There's my first entry, and that's what goes there. If we scroll using the right arrow, there's my next number. Okay, look like I've got a misprint. I put an 8 and I believe it's a 0. So that's going to be wrong, but I'm not going to fix it. This should be, let's go ahead and fix that. This should be a 0. In fact, I'm going to do this. Okay, the next number, 0.0366, etc. So there they all are. Okay, now just take your time, write them in, just takes a second. And if you go on down, the last one again, look what the last one's going to be. The last one's going to be in scientific notation. See, what we need to do is move that decimal 4 places, which means there's going to be 3 leading zeros. Okay, got that. So make sure your table agrees with mine. If not, just put your cursor and scrub back in the video and go through how we get those again. Now, we need this number here in the parentheses. Well, to do that, this number here is obtained by simply adding these numbers. And remember, this is list L4. So that's right, I just need a sum command. I need to find the sum of L4. Now let's do this again. To access the sum, we have to go into the list menu, which is accessed by hitting second and the stat button. And scroll over to math and then 5. Now let's put list 4 in there. So I hit second and the number 4. Close the parentheses and hit enter. Okay, so as you can see down here, that number is going to be right here. That's the 0.619. Let's do it like that. There's the sum. This is the sum of L4. Right here. This value right here, the 0.6192. That goes right there. Now, if you look at the trapezoidal rule, we need delta x over 2. Remember, delta x was 1/2, so this is going to be 1/2 divided by 2, which is 1/4. And here's all you do to finish the problem. You got to take this number times 1/4, which is, of course, equivalent to dividing that number on the screen by 4. And as you can see then, there's our approximation. So the integral from 1 to 3 of e to the minus x squared dx is approximately this value right here. And see, that's much worse than what we got with the midpoint rule. Now, if I put this back up here, I'm going to try to do this. In the midpoint rule, we got the point 1316. Fnth was 0.1393. This is Fn, which is the accepted answer. Here's the result from the midpoint rule. And notice the result from trapezoidal is not very good at all. You really only have 1 decimal place of agreement. Okay, so take a look at that. Pause the video. Make sure you get the numbers I got there. Now, let's look at Simpson's rule. Now, Simpson's rule is going to be the most accurate by far of the 3 techniques. The penalty for that is you must have an even number of subintervals, such as 4. So, same setup. Here's the problem. 4 subintervals. Here's delta x. And this is going to be exactly the same as trapezoidal. We draw our line. We put numbers to the endpoints of each subinterval. Now the subscript begins at 0, so 0 through 4. Where we start is 1. The next one is 1 plus delta x, 3/2, etc. Now you're going to get the same y values as before. Oh, that's the one I did a minute ago. Let's do Simpson's rule. Let's do Simpson's rule. And all I'm going to simply do is copy this over. They're the same. Okay, so Simpson's rule. Here's the problem. Integral from 1 to 3, e to the minus x squared dx, 4 subintervals, and delta x is 3 minus 1 over 4, 2 over 4, or 1/2. Okay. We draw our number line just like before. 1 to 3, 4 subintervals. This is x sub 0, x1, this is going to be 1 plus delta x, which is 3 over 2. This is 4 over 2, 5 over 2. Just adding 1/2 each time. So there's my first 2 columns. And these are already in list L1. Okay. Now we want to put the numbers from the y values. So this is going to be list L2. And again, the way we get that is simply y1 evaluated at L1 stored as L2. I'm not going to show that on the calculator because they're the same values we already have in there. In Simpson's rule, trapezoidal rule, the first 3 columns are identical. So let me take a handout here that I've already got completed, and let's go from there. So here's my table. Here's my table. This is just like last time in trapezoidal. Just like last time. Same values. But here's now Simpson's rule. And the first coefficient's a 1, then a 4, 2, 4, and they alternate. The third term from the end is a 2, the next to last term is a 4, and the final coefficient's a 1. So these will always be a 1 on the top at the beginning and a 1 at the end, and then in between they alternate 4, 2, 4. So this is 1, 4, 2, 4, 1. So all I need to do on my calculator is stat enter, and I want to take list L3, and I want that to be a 1. So if I down arrow once, I now change that to a 4. That 2 is okay. I make the next one a 4, and then hit exit. So all I need to do here is change the L3 column, or the coefficient M column. Now, just like last time, I need to take list L2 times list L3 and store it as L4. So this is going to be L4. So let's repeat that one more time. So here's, I need L2, the list L2, times list L3. And I'm going to store that in the memory location L4. And hit enter. And see, here are the numbers, 0.3678. The next one, 0.4215. And just scroll on through them. And I believe, just like last time, once we get to the end, this last one, the last number, again, is in scientific notation. So all you do is you take that decimal, which was right here, and move it 1, 2, 3, 4 places. If you have to move it 4 places and it's in scientific notation, that means there'll be 4 minus 1, or you'll need 3 leading zeros. Now, for Simpson's rule, we want to get this number that's in the parentheses. Well, this number that's in the parentheses is obtained by just adding these values here. So we need to find a sum of L4. So again, it's second, list, go over to the math menu, and it's number 5. So there's my sum command. Now substitute in L4, hit enter. So see, there's the number. I believe that shows up right here. See it? 0.83395. 0.83395. The 0.83395, the sum of L4, is this number that's in the parentheses here. Okay. So all I need to do to finish the problem, remember in Simpson's rule, this coefficient out front is delta x over 3. Remember, delta x is a half. So I want to take 1/2 and divide by 3, which gives me 1/6. So I need to multiply this number by 1/6, or the same thing, equivalently, I want to take my number on the screen and just divide by 6. So I get the value of the integrals approximated by this number right here. And just look how good of an approximation that is. Let me find the handout. Okay, here is Simpson's rule approximation, and this is the real value. Look at this. With 4 subintervals, this is the approximation, and we get agreement to 5 decimal places using just 4 subintervals. Absolutely amazing. So, okay, that's what your table should look like with Simpson's rule. Make sure you can get the values I got. Make sure you understand the coefficient column. That's the only difference between Simpson's rule and trapezoidal rule. It's just this coefficient column. All right, hope this helps. Have a good weekend.